Okay, so I did want to show you guys one example of solving these rational expressions. And so let's take this away. So if we start with this problem here, our steps are going to be the same each time. We're factoring the denominator. So that's what I did here. Just factor the denominator. If there's a denominator that's already factored, that's just kind of like nice, like this one. But anything that can be factored, X method, box method, we need to factor it. And then we find our LCD. And so our LCD is going to be each of these factors represented. So I have a x plus 6, that's part of my LCD. Every single factor in the denominator needs to be present in my LCD. I have an x minus 6. They're not the same factor. They're not exactly the same. One's a plus, one's a minus, so I have to include it. And then an x plus 6, but I already wrote that, so I don't need to write it twice. So my LCD is x plus 6 times x minus 6. Right from there, I can start talking about what numbers I don't want x to be. Any number that's going to turn the factors on the denominator to 0, I don't want x to be. So if I were to plug in negative 6 here, plus 6, that would give me 0. I don't want x to be negative 6. And if I were to plug in positive 6, here, I would get 0. So I don't want x to be positive 6 either. Right? And the quick way to do it is just to take each factor, set them equal to 0, and solve. You can do it with mental math also. So we have our LCD. We want to make sure now, and we know what numbers x cannot be. Now we want to make sure that every single fraction has that LCD. So my first fraction is 1 over x plus 6. It doesn't have my LCD. It has part of it. It doesn't have the whole thing. And if I look at my fraction on the right, it actually has the entire LCD. So this one on the right is fine. We don't need to do anything with it. The one on the left, which is missing a factor, we need to make sure we multiply by whatever factor it's missing. When I look at my LCD, I need an x plus 6. It's already got that. I also need an x minus 6. That's the missing piece. So that's why I'm multiplying top and bottom, numerator and denominator, by x minus 6. Right? And now I have the LCD on the left. I have it on the right. So now I can say, all right, every fraction has the LCD. Now I can set the numerators equal to one another. So my numerator on the left is 1 times x minus 6. Multiplying through that 1 is not going to do anything, not going to change. So it's just x minus 6. On the right, my numerator is x. So I just write that. There's nothing to multiply. And then, of course, I need to solve. Right? So usually we want all our x's on one side. I subtract here. I get x minus x is 0, so I get negative 6 on the left side. And then I also have x minus x on the right side, which is 0. So all my x's canceled out. I ended up with negative 6 equals 0, which is not an answer for x. It's just a statement. And it's actually a false statement. So what that means is that my answer doesn't exist. There's no answer. There's no solution because I got a false statement. Okay, so that's just an example of how to go through the process. If you end up with something like this, like a false statement, that's fine. Just say it's no solution. And we actually don't have to do the last 2 steps because we don't have any extraneous solutions to check or any solutions to check. If I would have gotten the answer, I would have just double checked. Is it one of my extraneous solutions, one of these guys? If it is, we X it out. We say it doesn't, there's no solution there. And if it's not, we just go back to the original equation. Just double check our work. Make sure on the test you are checking your work. If you're not checking your work, you're only getting half the points. So make sure if you do get an answer, not like this one, but if you do get an answer for X, you plug it in and double check that the left side equals the right side. Okay, so I hope that example helps. Email if you have any questions.